This is a video from section 7.8. Determine whether the integral is convergent or divergent. Evaluate integrals that are convergent. In example 1, we have the integral from negative infinity to infinity of x e to the negative x squared dx. And so I'm going to break this up at 0. So I'm going to go from negative infinity to 0 of x e to the negative x squared dx. And I'm going to add the integral from 0 to infinity of x e to the negative x squared dx. Now, let's go ahead and take a look at the integral from 0 to infinity of x e to the negative x squared dx. This is the limit as t goes to infinity of the integral from 0 to t of x e to the negative x squared dx. Okay? Now, this is the limit as t goes to infinity of. Now, the way we integrate this is we're going to get e to the negative x squared, but if I take the derivative of e to the negative x squared by the chain rule, I get negative 2x e to the negative x squared. I don't want the negative 2 there, so to compensate, I have to divide by 2 or multiply by negative a half. And I'm going to evaluate from 0 to t. So this is the limit as t goes to infinity of. I'm going to get negative 1/2 e to the negative t squared plus 1 over 2. So I'm going to come to the next page here. I'm going to get the limit as t goes to infinity of 1/2 minus 1 over 2e to the t squared. But as t gets large, this goes to 0, and you get a half. And so what that tells me is the integral from 0 to infinity of e to the negative x squared dx, that's x e to the negative x squared dx, converges. Well, we're not done. Why? Because we don't know anything about this one, this improper integral. So we broke up the integral from negative infinity to infinity of x e to the negative x squared dx into the sum of two improper integrals. If this second integral converges, we still have to figure out if the first integral converges. If the second integral diverged, we are done. Okay? So I'm going to look at the integral from negative infinity to 0 of x e to the negative x squared dx. But that's the limit as t goes to infinity of the integral from t to 0 of t goes to negative infinity, by the way, of x e to the negative x squared dx. So this is the limit as t goes to infinity of negative 1/2 e to the negative x squared, same argument as before, evaluated from t to 0. So this is the limit as t goes to negative infinity. If I plug in 0, okay, I get negative a half. If I plug in t by the same argument, I get plus 1 over 2e to the t squared, like this. But as t gets large, right, again, this should say negative infinity. As t goes to negative infinity, this second term is going to go to 0. and you get negative a half. And so what that says is the integral from negative infinity to 0 of x e to the negative x squared dx converges. Now, what that says is the integral from negative infinity to infinity of x e to the negative x squared dx is equal to the sum of two improper integrals that converge. For this reason, we can say the integral from negative infinity to infinity of x e to the negative x squared dx must also converge. And that's how you would work that problem. Okay? And with that in mind, we're going to take a look at another example here. Let's take a look at example 2. Suppose I had the integral from e to infinity of 1 over x ln of x squared dx. Now remember that the derivative of natural log of x is 1 over x, right? And so this is the limit as t goes to infinity of the integral from e to t of 1 over x times natural log of x to the second dx. So this is the limit as t goes to infinity of negative 1 over ln of x evaluated from e up to t. So this is the limit as t goes to infinity of negative 1 over natural log of t plus 1 over natural log of e. But remember that the natural log of e is 1, right? As t gets large, this term goes to 0, and so you get 1 over natural log of e, which is 1. And what we can say here is that the integral from e to infinity of 1 over x times ln of x to the second dx converges. Example 3. Suppose we have the integral of, or from 0 to 5 of 1 over cube root of 5 minus x dx. Now, there's a discontinuity at 5. So we're going to take the limit as t goes to 5 from the left, because we're going from 0 to 5, of the integral from 0 to t of 1 over the cube root of 5 minus x dx. So this is the limit as t goes to 5 from the left of the integral from 0 to t of 1 over 5 minus x to the 1/3 dx. So this is the limit as t goes to 5 from the left of the integral from 0 to t of 5 minus x to the negative a third dx. So I'm going to recommend pulling out a negative. So I claim I could write this. I'm going to take negative the integral from 0 to t of x minus 5 to the negative a third dx. And so this is the limit as t goes to 5 from the left of negative. Now, if I add 1 to that negative 1/3 exponent, I get 2/3. So this is 3/2 times x minus 5 to the 2/3, right? Evaluated from 0 to t. So this is the limit as t goes to 5 from the left of negative 3/2 times t minus 5 to the 2/3 minus 3/2 times negative 5 to the 2/3. When I plug 5 in, that becomes 0. And so this is going to be equal to negative of negative 3/2 times negative 5 to the 2/3. But this is 3/2 times negative 5 to the 2/3, right? Now, at the end of the day, what that says is that the integral from 0 to 5 of 1 over the cube root of 5 minus x dx converges. Now, your instructor, by the way, might want you to write this as negative 3/2. Well, actually, take that back. Keep in mind, this is 3/2 times cube root of negative 5 to the second power, which is a positive answer. But I would actually ask your instructor how your instructor wants this part simplified. So that'll conclude this video. This is section 7.8 where we did 3 additional examples. Thank you.